Hi, welcome back to paper 1, February, March 2016. We're now at question 8, which is differential calculus. If we look at 8.1, it says determine f dash at x from first principles if f of x is equal to minus x squared plus 4. So let's see if we can attempt this on the whiteboard. We know that f as a function of x is equal to minus x squared plus 4. Now, something that I would recommend doing is when you have a question given to derive from first principles, calculate the derivative how you would do normally. And the reason why I say that is at least you know whether you're on track or not when you derive from first principles. So if we use our normal method, we know that f dash of x should be equal to minus 2 times x. That's the answer that we need to be working towards. Now, if I just revert back, so the first thing we need to do is work out f at x plus h. Now what that simply means is wherever I see x in the normal function, I replace it with x plus h. So if I have to work out x plus h, I would then say negative, where I see x here, I would put x plus h. And remember that I have to put it in brackets just to make sure that it's done properly. And then I say plus 4. Now if I have to expand this, I then get negative, and then I open my brackets, I square the first, that's x squared, I square the last, plus h squared, then I take my first times my last times 2, which gives me plus 2xh plus 4. And that eventually works out to, if I expand it further, I then get minus x squared minus 2xh minus h squared plus 4. Now, just to refresh your memory, the way to calculate the limits, or the way to calculate the derivative from first principles, you will have the f dashed of x, and that's the derivative, is the limit as h tends to 0 of f at x plus h minus f at x divided by h. So the next thing we might consider doing is working out, and I'm just going to highlight this, or I'm going to circle this in green just to make sure that you understand that this is a critical equation. So the next thing that we can do is we can work out what is f of x plus h minus f of x. Now, so I'll write f of x plus h minus f of x. Now, if we do our arithmetic properly, I'm just going to write out the entire thing just to make sure that you understand it fully. So you've got minus x squared minus 2xh minus h squared plus 4. Now if I minus f of x, you can then see I've got a minus x plus 4, which means that negative goes into the brackets and changes the sign. So ultimately I'm left with is equal to minus 2xh minus h squared So lastly, what we do is we take this and we plug it in. So then we say f dash at x is equal to the limit as h tends to 0 of minus 2x h minus h squared all over h. Now what you'll notice is that we can then have a common denominator of h that can be pulled out. Sorry, we have a common factor of h in the numerator that can be pulled out. And if I pull it out, it cancels out the h at the bottom, and I'm left with the limit as h tends to 0 of minus 2x minus h. And if I drop the limit, I then get negative 2x. And that's my answer. And what you'll notice is that answer corresponds to what we worked out in the green at first. So that's how you would do it.